So in the last video, we talked about building the unit circle in the first, second, and third, and fourth quadrant. So now we're going to utilize this information to answer the questions in the examples below. So I'm going to turn this down to example 1 here. So for example 1, it's asking you to find the coordinate points for the given angle. So very similar to last time. The only difference here is that I'm adding more angles that come from different quadrants rather than it just being the first and second quadrant. So 210, if you were to look in the unit circle here, 210 is in the third quadrant. And so in the third quadrant, all the x's and y's are negative. So for 210, it's a root 3 over 2 negative and negative 1/2. So I'm going to copy and paste that here. That is my coordinate. So that's all I'm doing is writing the x and y value. For b here, this is 5 pi over 4. So I'm going to go to my unit circle at 5 pi over 4, which is 225 degrees. And this here is my coordinate. So again, my, actually that should be a negative root. I must have missed that. So this here should be a negative root 2 over 2 for both x and y since we're in the third quadrant. So I'll move this down and paste that here. So pretty easy. All we're doing is locating the coordinate, so the x and y. For this one here, it gets a little bit tricky because now we have negative degrees. So we learned before that if you have a negative degree, instead of going like counterclockwise where you do it in the positive direction, you have to go clockwise, which is the negative direction. So 90 degrees here, if we were to go negative 90 degrees, let's take a look at our unit circle. If you were to go negative 90 degrees, you would start on 0 degrees and move this way. So that direction is going to be towards 90 degrees, which is where 270 is going to be. So that's where negative 90 degrees would be. Thus, that coordinate there is going to be at 0, negative 1. So I'm going to go back down to part C and put in my coordinate at 0, negative 1. For this next one here, we have negative pi over 3. So if I go to the unit circle at pi over 3, so positive pi over 3 is right here, which is equivalent to 60 degrees. So negative pi over 3 would be in this direction, and I think it would be in the fourth quadrant, because it's only 60 degrees this way. So 60 degrees this way would be around 300 degrees. Take 360, subtract 60, it's about 300. So pi over 3 in this direction would be equivalent to 5 pi over 3. So what I'm saying is that if you were to move in this direction here, you would land here if you were doing negative pi over 3. So that is going to be equivalent to this coordinate here. So that's 1/2 negative root 3 over 2. So I'm going to steal that coordinate and write that here. So 1/2 negative root 3 over 2. Because we're in the fourth quadrant, so the y value is negative. Now that we have all of those coordinates, we are done with example 1. So we're going to check out example 2 here. So for example 2, they ask you to use a unit circle to determine if the function's even, odd, or neither. So in the last chapter, we learned that for evens, it means that if you were to plug in like a negative number versus a positive number into a function. So if you were to plug in a positive x or a negative x, they are equal to each other. Whereas an odd is the case where you plug in a positive x, but it is the same as if you were to plug in the negative x, only they're different signs. So they're opposite signs, but still the same value. And then if it's neither of these cases, then you'll choose neither. So first off, they are making us evaluate a trig function. So this one's evaluating sine, and they want us to check pi over 4 and negative pi over 4. So if we just go to sine pi over 4 on the unit circle, that is just, let's take a look. square root of 2. So here's pi over 4. Y value here for sine is root 2 over 2. And that's positive. Whereas sine, if you go the negative pi fourth direction, so negative pi over 4 would be in this direction, which would be equivalent to 7 pi over 4 if you were to go, 45 degrees this way. And so again, that's also square root of 2 over 2. However, this here is a negative. So sine here is a negative number because the y here is negative. So if I go back down to sine, for negative pi over 4, it's negative root 2 over 2. So because these are the same value but opposite signs, this is an odd function. So we have an odd function here. For cosine, let's take a look at what happens. So they want us to evaluate pi over 3. So we're going to go to pi over 3, which is right here. And for pi over 3, the cosine value is the x value, which is a half. So this is the positive pi over 3. For negative pi over 3, that would be, if you start 0 here, you would have to go about 60 degrees in the negative direction. So it's about right here at 300, which is equivalent to 5 pi over 3. Notice that the x value is also a half, and it's a positive 2. So both of these x values are a positive 1/2. So if I go back down, cosine of pi over 3 is 1/2, and cosine of negative pi over 3 is also positive 2, or 1 over 2. So in this case, this is an even function because they are exactly identical. They're both positive numbers. So this is even. And then the last one here, we're going to figure out tangent. Now, tangent's a little bit trickier because we need to figure out what is the tangent value for pi over 4. And that's not necessarily on our unit circle. We have to find it by using tangent is our y, do this in blue, our y over x. So if I were to find tangent pi over 4, let's go to pi over 4 for a sec. My y value at pi over 4 is square root of 2 over 2, and my x value is the same value. So if I take both of those values and find y over x, that's going to be root 2 over 2 over root 2 over 2. And we learned that if the two numbers are the same and you're putting them on top of each other, that means you're just going to get 1 when you divide. So if you take a number and you divide it by the same number, it's always 1. So in this case, my tangent here gives me 1 when it's pi over 4. Let's check out negative pi over 4. So for this one, again, I'm going to do y over x, but I'm going to do it for negative pi over 4. So I have to go back to the unit circle, look for that quadrant or coordinate. So if this here is positive pi over 4, it's about 45 degrees. So I'm going to go in the negative 45 degree, which would land me about right here at 350 degrees. So I'm taking 360, subtracting 45. That would land me right here at 350, which is this coordinate here, square root of 2 over 2, and negative square root of 2 over 2 for the y. So I'm going to take those coordinates here and write that out. Oops. So I would have for my y, the negative root 2 over 2, and for my x, positive root 2 over 2. And so if I divide, well, these two are the same values, only this one's negative. So if I divide, I'll get 1, but I'll get negative 1. So when you compare the positive tangent versus the negative tangent, they're almost identical, but this one's negative, this one's positive. So we have an odd function for tangent. And so I wanted you guys to try out that problem because I want you to notice the pattern. I'm going to try to shrink this down just a little bit, if it'll allow me to shrink. I don't know why that's not shrinking with it. I might have to just erase it. There we go. I'll just have to erase it. So let's just evaluate what we just learned so far. When we're talking about even and odd trig functions, cosine and secant, notice how cosine produce an even function, and that's the same case for all, cosine, whatever angle you throw in, if they are the same but different in signs, they end up being the same value anyways, causing it to be even. So that means secant, which is the reciprocal of cosine, is also even. So cosine and secant are both even function. It just means that if you were to throw in a negative angle versus the positive angle, they're still going to be the same value. So this is kind of showing that if you plug in a negative angle versus a positive angle, they still are equivalent to each other. Whereas sine, cosecant, tangent, and cotangent are odd functions, because what happens is if you compare a negative angle versus a positive angle, they're going to be opposite signs of each other. Like what we saw here for sine and tangent. So you can see here sine, when we plugged in the positive pi over 4 versus the negative pi over 4, they were kind of the same values but opposite signs. So that's what we mean by an odd function. So now moving into example 3 here. So for example 3, we are going to be looking for those trig values on the unit circle, specifically for an angle. So like if you're asked to find tangent, then you need to remember that tangent is going to be y over x. So you might have to go to the unit circle, figure out what your x and y is for 3 pi over 2. So let's go ahead and do that. So if I go to the unit circle for 3 pi over 2, I will notice 3 pi over 2 is down here, and the coordinates is 0, -1. So going back to that problem, so my coordinate was 0, -1. If I were to try to figure this out, my y here is the -1 over my x, which is 0. So if I were to divide by 0, you can't. It causes things to be undefined, so my answer here is undefined. And then that's it. So again, we're going to take our trig function, figure out what is the coordinate points at that point. So this is 3 pi over 2, so that's the same coordinate, which is kind of nice. But cosecant, like we've mentioned before, is equivalent to the reciprocal of sine. So you can take whatever sine is, in this case sine is always the y value, which is -1, and just flip it. Or if you go back to the identities here, the trig values, you can see that cosecant is 1 over y. So let's write that in. So cosecant is 1 over y, and y here is -1. So I'm going to pop that there. So that's 1 over -1, which is -1. So my cosecant here is -1. And that was my tangent. So I'll just box those two in. For secant, it's asking for 5 pi over 4. So we're going to go to the unit circle at 5 pi over 4 and just grab that coordinate. So 5 pi over 4 is both root 2 over 2, but it's both negative because it's in the third quadrant. So I'm going to write that down. So root 2 over 2, and they were both negative. Now, when I'm finding secant, if you look back at the trig identities, secant was 1 over x. So we're going to take our x value and put it in the denominator. This is 1 over x, which is equivalent to 1 over our x, which is negative root 2 over 2. So if I were to work this piece out, I'm just going to go this way since I have more room. I would need to flip this bottom fraction. So this is 1 times 2 over root 2. That's a negative root 2. So if I multiply straight across, this would be 2 on the top and root 2 on the bottom, which we can't have, so we need to multiply the top and bottom by root 2. So that would give me 2 root 2 and then a 2 on the bottom, but hang on, we're not done. Since those are 2 on the bottom and on the top, they cancel, leaving you with just root 2 that was on the top. So secant is equal to root 2 when it's 5 pi over 4. So that one took a little bit of work. Let's try out D here next. So D is sine, and it's a negative pi over 6. So we're going to go to negative pi over 6. Now, negative pi over 6 is in the opposite direction. So we're going this way. And pi over 6 is about 30 degrees. So 360, if you were to go 30 degrees this way, you would land at 360, which is also 11 pi over 6. So this is the coordinate that we need, which is root 3 over 2 and negative half. So let's write that for our coordinate for negative pi over 6. So that was root 3 over 2 negative 1/2 for that specific coordinate. So if I were to solve for it, I need to take, well, sine here is my y value. So all I need, I guess in this case, is just negative 1/2 because sine here is your y value. And that's all they ask. So I have sine. For cosecant, negative 3 pi over 4. Let's take a look and see where that is in the unit circle. So negative 3 pi over 4 is equivalent. So let's take a look at the positive version. The positive version is right here at 3 pi over 4. So the negative version is going to be a reflection of it across the x-axis. So it would be this guy here. So if you were to go about 135 degrees in the negative direction, you would land at 225, which is equivalent to 5 pi over 4. So this is the angle, or the coordinate that we're using. So it's negative root 2 over 2 for both x's and y. So going back to that problem, I'm just going to rewrite the coordinate here so I don't have to look back and forth. So my coordinate is this here, and they want cosecant, and cosecant is the reciprocal of sine. So this is going to be 1 over y, and my y here is root 2 over 2. So this is going to be 1 over root 2 over 2 negative. So I would have to, switch it. So this be 1 times 2 over root 2 negative. And so that would give me negative 2 over root 2. But I would need to rationalize the denominator. So that would make the bottom here a 2 and the top a negative 2 root 2. But since the bottom and the top both have a 2, they can cancel. And so that gives me negative root 2 as my answer. So I'm just left with that negative sign that was on top and a square root of 2. So that was a little bit long, but you can see cosecant here is negative root 2. For cotangent, I'm going to go to my unit circle at 11 pi over 6, which I think is in the fourth quadrant, but let's just double check here. So 11 pi over 6 is right here, and my coordinate is root 3 over 2 and negative 1/2, and it is in the fourth quadrant. So this is going to be root 3 over 2, negative 1/2. The y is negative since we're in the fourth quadrant. And cotangent is the reciprocal of tangent. So instead of y over x, you're going to have x over y. And if you were to write this out using the x and y values, your x here is the root 3 over 2, and then the y value is 1/2, but in a negative. So working this out, you might need to flip the denominator. So this is root 3 over 2 times 2 over 1. And multiplying that out, I noticed that the negatives, or sorry, not the negatives, the 2's cancel. And so that gives you negative root 3 over 1, which is negative root 3. And so that there is my cotangent value. So that's it for example 3. In the next video, we'll be looking at example 4 together.